Everyone, welcome to another KE Report webinar. I am your host, Corey Fleck. We are doing this webinar in conjunction with Focus Communications, and we are happy to have on Graphene Manufacturing Group, also known as GMG, and traded GMG on the TSX Venture Exchange. I am joined by two company representatives here, Craig Nickel, founder and CEO. Craig have talked a lot in the past on other webinars and interviews for our show, KE Report. We also have Chris Ulrich, the CFO and Executive Director. Now, these guys are going to talk through a presentation that you can all see on your screen. We also have a number of questions that have already been sent in to us, and you can continue to submit your questions through this platform. There is a chat feature. We do ask that you use the Q&A aspect, but we will be monitoring both aspects of that chat. We will try to get to as many questions as we can, but as I mentioned, we already have a lot that have come in. So I don't want to take up any more of your time. We will get Craig and Chris to work through this presentation, and I will be interjecting some of these questions as they fit in with certain slides. So Craig, Chris, thank you for joining us, and please take it away, guys.
Thanks, Corey. Appreciate to catch up again. It's always good to see you. And Chris and I are very happy to have a chat with yourself and present this update to you, and obviously get questions and to interested investors / shareholders. So let's get underway. Obviously, TSXV GMG is our ticker, and we're also trading in Germany. Usual disclaimer for forward-looking statements on very high growth capital companies like ourselves, and just an update. Obviously, a summary that the GMG is obviously a disruptive clean technology. So if you haven't seen any presentations on us before, a company that we're pulled together by a common connection. Like most of us are ex-Shell, and we've developed our own way of making graphene from natural gas, and only natural gas and electricity, and we are able to make a very high quality, low cost, scalable, tunable, and low contaminant graphene. This is held by a proprietary process, as held as a trade secret, and also a number of product patents that we're progressing through the patent process. We've targeted specifically energy savings and energy storage solutions with these products, and we're obviously including one of these products is our next generation graphene aluminium-ion battery, which a lot of people are very interested in, and we have some other products out in the market as well, so we'll talk through those. So the board is a mixture of ex-Shell people as well as capital markets people in Canada, and so probably don't need to say much more than that, but there's a lot of experience here of being able to run very large businesses with multi-billion-dollar assets in energy supply chains, and that's what GMG intends to be. So we believe we're building the team, or have the team already, to be able to grow into that and execute it. So what is graphene? Very quickly, it's seen as a wonder material. I wonder what I'm going to make out of it is often the question as well, because it has so many different amazing parameters. And so GMG has done an enormous amount of trials with its own graphene, which is very specific to its process. And we specifically focus on the thermal conductivity, enhanced lubrication, and in ion storage, in being able to store ions or in batteries for energy storage. And the graphene is a carbon that is very small in dimension and has a very really interesting properties because of its dimensions and because of its size and shape. So when you change the dimensions and size and shape, you do actually get different properties as well. For those who haven't seen it, it's a black powder. So for all its magic, it actually looks pretty simple, and that's part of its charm, I think. So it's GMG's competitive advantage is being able to take natural gas and split it into hydrogen and graphene, and focus on the graphene, and then use that graphene in products that then can go into energy saving and storage solutions markets. Other graphene companies take their mined graphite, they distribute it, crush it, then they look at chemical processing, washing, and chemical processing, rinse and repeat 7 days or so. You again get a graphene oxide, and you then get these other contaminants. And in some cases they're helpful, but a lot of cases they're not helpful. And that seems it's a very different product, whereas ours is really just pure carbon.
How about, Craig, let me jump in here real quick. General costs. People have been wondering how much it costs, or the projected costs to produce, say, 1 kilogram of producing your own graphene compared to what third parties might cost.
Yeah, so it basically comes down to 3 things: cost of methane, cost of electricity, and cost of labor. Cost of methane is natural gas. Is which country are you in? Right now, it's pretty low cost comparatively with everything else we have. If you look at our P&L, it pretty much shows that the cost of goods are always quite low, which obviously doesn't include labor. We can go on about that. Electricity, there is a bit of electricity, which we currently use solar power, and we obviously aim to have eventually that hydrogen do all the powering with batteries and solar to power electricity. So that cost would be managed in a mix of, some type of asset depreciation with solar power costs coming off, and then potentially some grid. And then you're then with labor, and labor is really just a fact of automation. And we're continually automating or increasing the ability of reducing our labor cost. But that'll come at scale as well, and that's what we're chiefly focusing on. So if you put a very low cost of gas and electricity into it, and then you have huge automation, it is easily the cheapest graphene out there. And that's the focus of probably a few years ago. Now the focus for us is really making sure that the quality is exactly what we need to be. You can't have more than one master. You need to have one master when you are optimizing the process. And our master right now is quality. So we're chasing the quality for our battery grade graphene, which we'll talk about later. But it's always in a context of very low cost atmosphere, low cost focus, but with the fact that we only have those 3 input costs. There are very minor other costs. Otherwise, it's a small amount of packaging, but that'll go away when you start to scale. So you're really talking, potentially the cost of our graphene would be what most people would pay for their graphite. It's that low cost, but it's in the end, it's not about that cost. It's actually about the quality that you want to have for the application, so that it always works.
Okay. Is there any constrictions or restrictions on how much you guys can produce?
Well, we have enough plant equipment right now to produce what we're trying to do. We don't have any restrictions per se to stop us selling thermal XR and lubricants and making batteries. Well, we can talk about our battery quality shortly. But no, not when we go forward and we need to scale into very large production, that's when we'll start to get focused on increasing production. But right now, our production is not the constraint.
Okay, thank you.
Yeah. So we obviously take the graphene, and so a couple of years ago we were focused on graphene and looking for the market and how can we develop that powder market, and we've definitely transitioned now into 3 products, and there are some others that are lurking and they try to put themselves into that top 3, but these are the top 3 we're focusing on. That's thermal XR, our graphene lubricant, and our graphene aluminium ion battery. They're in the market in some way, and hence that's why we talk about these, and our focus is our strength. We need to focus. There are so many opportunities with this product and this material and this business, and so these are the 3, and that's what we focus internally on, and also what we talk about externally too.
So, Craig, have there been any issues that you guys are experiencing with the rise in natural gas prices and any of these supply chain issues that could be impacting you?
No, it's because we have a natural gas pipeline from the grid. There's no supply chain issues there. Australia's natural gas hasn't seen the price rises that say other parts of the world have. We saw them much earlier, about 10 years ago when other things happened. So we've already got reasonable high prices here for retail pricing, that is, which we currently buy off because we use so little as an input. So no, not per se. But there are some supply chain issues around just moving things around, logistics, getting things to customers internationally. That's definitely more difficult with COVID restrictions or with the current economy as well. But nothing on the input side right now.
Okay. Final one before we move on. This question just came in regarding hydrogen. Hydrogen is a byproduct, I guess. You produce graphene and hydrogen. What do you do with the hydrogen on the back end?
Yeah, currently we either do two things. We vent because it's just hydrogen will form water when seeing an oxygen atom in the air, or we put it into our cogeneration plant to power the process, depending on what we're doing. The end game is we'll take it all and we'll put it into the cogeneration plant. Of course, we don't take all of the methane and convert it all into hydrogen. It varies depending on what process and what product we're making. It can be as high as 50%, but even higher sometimes. But right now we do either one of those things. But in the future, we really do aim to harvest it. And when we're a big battery company, that's we will be a pretty reasonable scale hydrogen producer, and we'll probably work with someone to take that away and go sell that into another market. We don't really want to go and get into that business, and we've got to get focused, keep our focus. The scale size will introduce more hydrogen production, and then we'll try to work with someone who can take that away and make that into something for someone else, for the hydrogen market. We'll get into this. People are wondering what the overall addressable market is for these. So this answers that question then. Sure. So our three products here show our addressable market, and 26 billion is seen as the cost reduction for a certain amount of electricity for a certain amount of commercial ACs around the world. That's the market that we believe is addressable for our TXR coding system. And we are looking at the various different ways of attacking that market through various different route to markets. And obviously, because it's installed already, so how do you get to the installed market? And then we're also trying to talk to people in OEMs as well, so in the original equipment manufacturers. So there's that market is it's a large market because of its installed capacity, and it's one of the largest CO2 emission causing activities in the world. Obviously, you generate the power somewhere else, and that's where the emissions come from. But now with the lubricants market, that's a known number because it's lubricant additives have been around for probably 100 years. So that's a known market, and there are multiple ways through that market. There's various different blenders that we're talking to, tiers 3, tiers 2, different parts of the world. But tier ones, they do take their time, and also there are additive companies that we're talking to that can go to multiple tier ones, and so we're progressing through those. Now the aluminium-ion battery is a really quite a unique battery because it could replace your lead acid battery in your car. It could replace the phone in your battery in your phone. It could replace pretty much any battery there is. It can look to replace because of its very unique battery supercapacitor hybrid status. I think it's probably one of the only types of batteries like that, where it's very fast charging and discharging as well as good storage. So hence that market size is quite large. And it includes all the various different batteries that I was just talking about. Obviously, one of the fastest growing markets in the world right now, or physical markets.
Now, Craig, we have a lot of questions on the battery component here, but we do have one question, actually a couple questions that have come in asking just for an update on the Thermal XR, because we had some preliminary data back from last year. We haven't heard much about this recently. What are you seeing in some of the testing that's ongoing with the Thermal XR division?
Yeah, it's there's a lot of data that's being pulled together, and that data has shown us that it's a high performing product in being able to save people energy in different humidities, in different temperatures, and even in different kind of environments like deserts and things like in the Middle East, where you just get sandstorms coming in and blowing on air conditioning units day in, day out. So that gave us a lot of data that enabled us to understand how it works even better. What we've also done in the past few months is actually look at how it works on a brand new air conditioner, and we're seeing some good savings there as well, as much as 10% we've seen. Now, 10% on a new air conditioner is something that air conditioning companies will chase, with an enormous amount of work. Is what people in the industry have told us, and they'll pull apart the whole air conditioning unit, to even certainly big ones, to be able to get that kind of efficiency gain. So it is opening up the OEM market for us, the original equipment manufacturing market, and that, I think, that just gives us another very large channel. And so, whilst we continue to do projects in Dubai, Singapore, and Australia, we continue to progress with customer conversations and other route to markets. We'll continue to get more data, more proof of concept. Then I think we'll, one day I believe we'll get some material revenue in, and that day will be a good significant progress for the group, because we're heavily focused on it, and there's a lot of work going into it. We are doing some things there that take a bit for people to believe, and the bigger the gain that you have through something that is potentially as strange as painting graphene onto an air conditioning coating system, the bigger the data proof you have to show to people. And that's what we've had to do, and we continue to work that through. And as I said, we're looking at different channels as well, and looking at all options. There's some good discussions going on, and there are some material revenue discussions, but we haven't got there yet. And obviously that's what we're focusing on heavily in our sales and marketing team.
So, Craig, real quick too, there's people are asking for some updates here on this Ofella LOI, what some of the work is that's moving forward in the Middle East. What updates can you give us? When can we expect some more news on this front? So
this is a Pena, I think we're talking about, who we've got some project work done over in Dubai with our partner, and the project work so far has been showing some quite good energy savings, enough for that to continue into further discussions. We've done project work from large a building, whole skyscraper air conditioning, through to medium-sized air conditioning units, cassette units, and then all the way down to small split systems. And it is a very complex weather pattern. If you've been to Dubai, one day it could be this, and the other day it could be that, and it could be humid one day, and then it could be 15 degrees warmer the next day. And one block is different to the next block because of the wind differences. So all of that did definitely set back the amount of data we needed to get together to prove the air conditioning coating. It's not like Singapore, where you can pretty much set your clock by the 4 p.m. rain, and you could get a regression data that's 99.9% accurate, and some parts of Australia is the same. So we've had to work through that, but right now the work is ongoing. There's a lot of good, strong technical work, and a lot of good commercial conversations happening as well.
Okay, thank you. Hold on, there was one more here. In terms of energy reduction, we're seeing energy reduction varying from around 5% up to almost 60%. Why is there such a large gap here?
Yeah, so there's a few things going on, and I won't try to take up the whole time with this, but I will try to get to the bottom of why that's happening. With an air conditioning, you've got three basic systems, and we're improving right now. We can do the other three, but right now we're only focusing on one, which is the condenser coils, and that means that there's we're really only looking at increasing the efficiency of that one system. But if the other two systems are still quite inefficient, then they will set the pace for how much we can get out of the equipment. So when we improve one of them, and then obviously you have the evaporator coil, which is a bit inside, and then you've got the refrigeration circuit, but when you improve one of them, the other two can still slow that down, and hence that's definitely part of it. Second is that there is a bit of cleaning that we do. So when we have fluids that clean the air conditioning coils, and so sometimes there's there could be some big gains that got out of cleaning. But I have to say that is not that's not a sustained cleaning. Once you clean it, it can take only a few months for that to come back. So when you clean it and then put the TXR on, which then makes sure that the dust environment has less place to settle onto the coils, then you'll have a much greater chance of sustained energy reduction. And then it's obviously a lot easier to clean the graphene with another fluid that we have. So hence, that's I should explain the variance. The fact that we can get 10%, and I've seen up to 20% on brand new equipment, means that which obviously we don't have to clean, we don't have to etch. There's some corrosion that we take out, which is the etching, which is the second step. There's definitely a step around just how inefficient the existing air conditioner is, and that's the one that it's a bit difficult to get to on every understanding until you actually go and do it.
Okay, thanks, Greg. Let's move on. I know a lot of battery questions, so let's go with that.
Great. So, this is an increasing knowledge exponentially. I'd say almost every other week we have more and more data come from all the work that we're doing, building the pilot plant that we're ongoing with our other work on top of the coin cell pilot plant we've already built. All of the work with UQ, and the scientists that we've now hired, and we're building that team, and also engaging some very large companies who, quite frankly, are some of the biggest buyers of batteries in the world. So all of that is generating our knowledge around this. It's it's basically a graphene and aluminium battery, and there are a few levers. But even those few levers of getting the design optimized and learning how it works means that it can be, you've really got to do a lot of work to get to know the understanding of every different system and design of what you're trying to get out. So there's, I have to say, we've got some really good results, but we know that there's enormous levers and low-hanging fruit coming forward. And everything we've learned so far shows that this is an amazing technology. It really is. It's extremely fast charging. It's good energy density. It's got many thousands of cycles of discharge and charge and discharge and charge, and then when you can pull it apart and basically reuse it. It's an amazing piece of tech, really, and it's a pleasure to work with. And it's just what's going to get us there is just pure grit. Just keep pushing through an enormous amount of questions and answers, and working with some very large companies that can hopefully bring this to bear faster, at scale faster. So,
Greg, what is the general material breakdown of the batteries then?
Yeah, so the two main materials, and you're talking, say, 90% are graphene, and that has got some small atomic holes in it. And then the other is aluminium chloride, which is aluminium and chlorine mixed together. So those two are the main products, and that they vary in the percentage of what you're trying to do. But the end game is you would want 3-4 times more graphene than the aluminum chloride, and hence your energy density goes really quite high. So your graphene is your cathode. It's on a piece of carbon paper or carbon cloth, so very basic material. And then your electrolyte is aluminum chloride. That's all it is. There's a tiny bit of fluid to attach to that. And then your anode is aluminum foil. And then you have a separator, which is a very thin film separator, which separates the two, cathode and anode. So that it's a very basic battery in its simplicity, but it's enormously advanced technology to be able to make it that basic. So it's basically around the technology to get it to scale at a really high energy density, which can be much higher than where lithium is all around using as little aluminum chloride electrolyte as possible, and using as much graphene as possible to get to store ions at as high density as possible, and that's the secret. And the battery is pretty much every battery we make is always fast charging and highly and cycling and recyclable. That's not the issue. It's just how much graphene can you get in there to store the ions or to be able to create the energy density. That's what all the trick is. And there's some really good work done, and we've got we can talk about the prototype shortly, but we've got some really good potential companies to help us progress this, and that's what we're going to need to get this at scale fast.
Okay, thank you.
So this is how we make the holes. We're pretty much focused on this particular type of graphene in the middle here, and we try to make the holes in a certain way. It's a chemical process. We don't physically drill the holes. They actually they're atomic level holes. So that's a bit of a nanomaterial joke, but we chemically strip the graphene so that it creates these holes so that there's more ion storage, and that is the technology that enables this battery to work as a supercapacitor as well as a battery.
How difficult is it to scale up this nanotechnology? How much work goes into that?
If once you've got repeatable, reliable graphene this scale, which we can go on about shortly, the process to strip that in can be easily automated, probably continuous, maybe batch, but we'll try to get to continuous. And then it's then using this battery is then using the same equipment that lithium-ion batteries use to make. You're just putting different chemicals in the feedlots, if you like, of the equipment. So I'd suggest it's. I think people are going to be quite surprised on how quickly we can bring this to market. Obviously, we haven't done it yet, but there's a lot of good indications of how prepared the industry is to be able to A, receive these batteries, and then B, be able to make these batteries with existing equipment. And that's one of the main reasons why we chose this technology, because we have a number of technologies to look at and be interested in, because that graphene can be used in almost all batteries. And we like this technology because it's using existing manufacturing techniques, processes, equipment, that it's at scale. It's all been proven. We're not developing a new way to put cathode and an anode together with separating between.
Okay, so you're not reinventing the wheel then, right? You're using some different components and a little bit different of a process here. So I guess essentially it shouldn't be too hard to scale when needed.
No, we don't think so. And of course, we've got Bosch as a partner in the battery space, and then we're putting together partners in the graphene space, and obviously we'll hope to have a partner in the battery space, in the final battery space, in applications. And so you put together this coalition of the willing to be able to bring this to bear. We'll need a supply partner for other different parts of the products and materials as well. So we'll bring this to scale in a way where we're already working with companies that are already at scale, and we'll basically be surrounded by companies who can lift us through to scaling faster. That's in my work, and obviously the work of most of the teams. We put together these very large multi-billion-dollar value chains in our previous company, and that's what we're trying to do here. We're trying to put together supply chains that can operate at scale, and basically we're going to plug ourselves into that as best we can, rather than trying to learn how to work with smaller or other companies that are just trying to scale themselves at the same time.
Okay, thanks, Greg. Let's move on. Everyone wants to hear, it looks like, about some results and revenue and all that. So I'm sure we'll get to all of that.
Yep, great. So this is just showing you the other graphene aluminium batteries that have been done before. We put this out last year. These are calculated energy densities. So there's a very clear energy density advantage with our battery over Stanford's prior one, and also power density, which is the ability to charge and discharge. That enables us to basically get a battery that can, if it was in your phone, it would charge in a minute or so. You would need, so your cable to charge your phone right now is sized around, as most people would know, sized around the amps. This would be much more amps flowing through the cable. So your cable to charge your phone would have to be bigger. So I did see a question about that. And yes, the cable would have to be bigger. It's not for the volts, but for the amps. And I think most people would be okay with that. If they can charge their phone in a minute, they probably would go, that's okay. I will get a bigger cable. I can take that. But when you start talking about EVs, you've already got a big cable. So EVs are another conversation, because what you're saying is the battery isn't constraining it. How much infrastructure do you have to charge that battery faster? And that's where the conversation gets a bit more interesting. But where you've got a phone charger and the cable's this thick, and then you need to make it this thick, well, that's a bit easier because the cable can be upgraded a lot simpler. So this is the money slide. We show this to some big battery buying companies, and this is the one they always they stop and awe over. Thousands of cycles, very high capacity, and but no deterioration. It's really quite an amazing thing. You're talking in the end there about 300 times faster than your normal phone battery charging time, 10 amps per gram of cathode. So I don't think I need to say more than that. That's obviously still just doing coin cells.
A lot of people want to know, compared to typical battery, and you have that little arrow there that says typical battery tech. What is the big difference here? What do people like about this more so than what we already have?
Because, you typically get about 600 to 1,000 charges, discharge and charging cycles in your phone battery. I'm just using the phone battery because that's what everyone understands. And then it starts to deteriorate about 60%, 40 to 60% down. So you'll start to realize that your phone doesn't go through the whole day. So it might last half the day or 3/4 of the day, and then you've got to top it up at work. And then you go, oh, I need to get a new phone, but I won't because that's kind of wasteful. So you suffer it on for a bit, but then it starts to get to a point where it might only do 4 or 5 hours, and you go, okay, I need to get a new one or change the battery. That's what we're talking about here. That's the deterioration of the lithium battery, and that's what happens with the lithium battery. It forms dendrites of lithium, and there's less area for the ions to store because the connections in the battery are shorter. So it starts to form areas where the ions can't store, and there's less storage for the ions, there's less capacity, and it starts to deteriorate. With an graphene aluminium on battery, you don't get dendrites. So that potential for the forming of those dendrites to stop the amount of ions you can store in the battery is less and less. It is not there. That doesn't happen as a function of the battery. So as a result, you get a chart like this. So people who know aluminium-ion batteries know this is what you get, and so they're not surprised.
Okay, thanks. We can move on.
Mm-hmm. So we're obviously got some. We've talked about it before. We've on your report a number of times. We've got a number of large brands who've responded, reached out, want to understand how they could do collaboration, get some testing, batteries testing, and potentially purchasing for their products. And these are the range of different applications that they want to see this technology in. Personal electronics is the biggest market that's out there right now. EVs are definitely coming up, and they'll probably soon overtake personal electronics, if not this year, maybe next year. But you've also got house and grid storage. You've got aviation. So electric aviation, really trouble with lithium-ion batteries. We've probably got over 10 electric aviation companies around the world who are kind of into that NDA stage, and we're talking to them about how we can help them. But there are two main formats that they would need to use these, and that's a coin cell battery and a pouch pack battery. We want to use a pouch pack battery because it's quite space efficient. It's called cell to battery efficiency or coefficient, and because they're just blocks of units. So we want to use something along those lines, and we could possibly use them in all of these different applications. And then we probably won't go into a cylindrical battery. I say that because we don't need the cooling that the cylindrical battery offers or looks for. So that's what we believe right now. So that's why we're actually focusing on the coin cell and pouch pack. That's why we have a coin cell battery pilot plant, and that's why we're working on a pouch pack battery pilot plant, and we're hopefully bringing that to operation shortly. So these are the types of range of applications. We've got some big companies in there. We've got some medium-sized companies, some really innovative startup companies who can show how a battery can work in innovative ways. And we aim to give them coin cell batteries and pouch pack batteries to test, hopefully sometime during this year. And obviously with coin cells already out there, and we'll just keep testing into different specific applications with specific potential customers, get that feedback to optimize and progress and develop, whilst we're already developing the science as well. How
quickly do you get some of that feedback? Because a lot of people are wondering, what have some of the people that have gotten these coin cells, what have they said? What are we learning about this?
Yeah, I'll stay on this slide. So in a future slide, there's actually some points around what we got back from our samples, okay. So I can go on about it then.
Sure.
So UQ has progressed to the PCT, which is the global patent organization, and we have a 20-year license agreement with them, and that has if the patents last longer, then it extends to that. It's basically for the life of the patents, and then we pay a royalty on the sales. It's an agreed royalty, which enables us to get the scale. So there's a discount for a short period of time before we get to scale, hopefully after a period of time. So that'll be progressed into country level patent status, and that's when you actually get to get a patented outcome. The PCT really enables you to enter into countries around the world that you want, and then you drop into the country status process thereafter. And so that's what we'll work with. And what's great is that University of Queensland, obviously, and UniQuest, their commercialization arm, they've been here before. They've done this on some very major discoveries and IP and patents. So quite comfortable. We'll progress through this. It is genuinely, in our eyes, it's genuinely innovative and novel. What they've developed with the holes in the graphene, that's most of it, and then the ability to put all this together into a battery as well. So the process and the product.
Do you guys have a general time frame on when that patent could be issued?
It's not. It's per country, and each country kind of does do their own thing, their own timeline. But you're talking 18 months or so. Most likely that'd be secured in different countries, and probably not much longer.
Okay.
So we've talked about it before with our non-binding letter of intent project kickoff with Bosch on collaborating on how we're building our battery plant. They'll be building the battery plant for us, and then we'll operate it, we'll own it. So they're our effectively our contractor, as much as you could call someone a $500 billion company a contractor. But they're effectively our contractor to design and install and commission our plant to enable it to have that peace of mind that you run a plant like this that you want to run a plant at this. This could have been done otherwise. We could have done it ourselves. We could have recruited battery processing automation engineers. We could have put together a consortium, some robotics guys and some other companies. But Bosch and us have, I think, a pretty solid connection, and we're working with them to progress this to a state which, we can put together a plant, obviously following a final investment decision from the company and a few other things, including likely a sales agreement with a battery buying company. So in good progress, working through it. Very happy that this is definitely, we kicked this off last year and it's going to pay dividends. And obviously we want to add to these types of partnerships to progress us at scale faster. So
can Bosch scale with you? Is there any ongoing agreement with them, or is it simply just that pilot plant? The ongoing construct is that we would go to them about our battery manufacturing needs. So, when we need a pouch pack, they have a company that makes pouch pack manufacturing equipment. There's about 40 companies around the world that make pouch pack manufacturing equipment. One of the things is getting access to it. There's everybody in the world trying to build these factories. So actually having the access to a company like that actually is one thing. It's a tick. But also having some people to bring it together and make it all work and connected with our graphene plant is another massive tick as well. Okay, fair enough.
So pilot plant, we commissioned this at the end of the working month of December, just before Christmas last year, and it was quite an achievement to have this operational. There's our chief scientific officer and our laboratory scientist, Anitha. We're going to be building that team out because we need more hands and minds to make this work, as we were saying before. But enables us to make our coin cells in-house. We've still got more work to build this into the same battery capacity that we're getting out of UQ, because obviously UQ has been making it for some time, and we're transferring that IP across. It's technical IP transfer process, so it's only been operational for a month, but that we believe will be done pretty shortly, and then as we build a team, we'll then start to grow it even. Where we see UQ right now, we'd obviously start to hope to think that would be much bigger in terms of the performance we're getting, the higher performance we're getting at UQ.
Real quick, you mentioned team. We've had a lot of questions asking about how big the team is. How big is the team at GMG?
Yeah, so we're about, I think, close to 30 people, including board. So it's not a big team, and we need to increase the size of the team to be able to deliver on some of these commitments that we're going to have to make or have made to some pretty large companies to get these prototypes out and shortly our pouch pack out, and obviously working on TXR sales and marketing as well. So you're really talking about kind of a third of the team that's really pushing the graphene production quality tuning process, and probably a third of the team that's really pushing the batteries, and then maybe a third of the team that's really pushing the coin cell plant development. So and how that links with the company and the companies we're talking to. So the team is fairly stretched, I have to say, and we are adding, and we will add more people because it's when you've got some pretty large companies that are trying to engage with you, you need to bring your A game. You need to go through all of the hard work and bring your A game. That's what we've done for 5 years, and I don't see why we won't be able to continue to do it. It's the team that's got us here, nothing else. So I think we'll continue to grow, and that's what obviously the board and I are very focused on, and how we do that in the right way, bring in good people at the right time, and get them on in the right priority as well. Because the fact is, we all need more people in the team, but we've got to get the right people at the right time and focus on them. And that's the trick to it. And so far, we've done it okay, and I think we can continue to do that. So we're obviously still waiting for some customer feedback on these coin cell samples that we shipped out at the end of December. Some of these guys have actually got other priorities, like they've got chip shortages. They've had to change chips over for battery management systems, so they've had to reprogram new chips, and so teams have been put onto that. And others have just flatly just come back from their festive holiday and are really looking to work out how to get their day year underway. And I think that obviously we need to get it to 3 volts. We're currently 1.7 volts. We don't actually anticipate that being a big problem, but we just need to do it. We have had some initial feedback, which is verbal, with one potential large customer, and that is that we do have some. We are showing some very high area capacity versus lithium-ion batteries, and that's one of the key things is that you get a certain amount of capacity of the battery per square centimeter, and if you get enough, people say, "Oh, that's where you're at." And we've already had some good feedback to say we have enough without them actually testing it, but on the data that we've proposed to them, so they need to go through their testing side. It's only been positive so far that we received. We've obviously got a lot more development ongoing, and we'll continue to do that with our pilot plants. And we've got our pouch pack pilot plant battery format coming in, and it's been somewhat delayed by about a couple of weeks because of freight, which I mentioned earlier. But we aim to have that up and running before end of June 2022. So that'll enable us to start putting pouch pack batteries out and getting samples back, responses, and understanding what feedback we get and optimizing around that for the pouch pack. So that just means we need more people to make that happen as well.
So it sounds like you haven't received much feedback on these coin cells yet. I understand that there's a lot of other issues that companies are dealing with, but when do you expect to get some of this feedback? Do you have any timelines with these guys that are testing out the batteries to start giving you some of their test results?
Yeah, I mean, I think it's best to say they will give feedback in a way which suits them. I do think that what I do think we'll find is that the customers will always want more and want this and want that. And, I think the biggest feedback we'll be asking for, the clearest feedback is a contract to supply batteries. So at some point, that's where we aim to be. So I think what we'll aim to share with shareholders, and investors is the qualified feedback that says this is, the areas we need to do more work on, and these are the areas that they're thinking that are quite in the ballpark already. So that's probably the best way to describe how we're going to go forward, because each potential customer has their own specific needs for the application, and these batteries are very highly multi-dimensional, as all batteries are, and how you make the battery for the particular customer will work for one, and then the next one might come along and go, "Oh, yeah, that's interesting, but what I really want is this." So that's something we've got to work through, and there could be some big choices to be made, because we may not be able to take care of everyone's needs. We may have to be quite careful in saying, well, this is what we're going to do. Are you still, how does that fit into your your product and applications? What I have been told is, and take this for what it is, but somebody else's point is that eventually people will just come and say, I'm going to design my product around your battery, GMG. That's what I've been told. But until that point, we still need to make a battery that is around the customer's application and fit their existing needs. But at some point, we're just going to say, well, this is the battery we have, and then other people will hopefully then design it around that, if that makes sense.
Absolutely. And I think a lot of people are wondering that, right? When do you take that step to get to that revenue, sign some bigger deals?
Yeah, and then commit to a certain battery type that then means that your customers have to make a choice, because that's what in the end we're probably going to need to do. We're going to need to make a choice, and that's going to be after hopefully as much validation of our what we can do as possible. You don't necessarily want to only have one or two or five or even six. You want as many companies saying this is what we think works and this is what we think you should work on, and then out of all that go, well, this is where we're going to go, and that's the battery we're going to make. And of course there's pouch pack coming on, and pouch packs are any number of voltage, size, capacity, shape, volume, discharge, charge capacity, and rates. So there are, then pouch pack is, you've got anything goes, whereas coin cell, you do have some constraints because there's a certain size that you need to fit. So that's why we're doing coin cell, because it's a bit easier. So, I think we're conscious that investors and shareholders want to see from us, well, what did potential customers say, and and I think, so I'm very conscious of that. But I think there's going to have to be some evolution of the product with the customer, with the investors on this point. And then when we really do know, we will tell. We will say what we've got back and how we're going to go forward.
Okay. And then I guess last one before we leave the coin cells, but we do have a couple on the pouch pack. Getting up to that 3+ volts, how is that progressing? Are you going to be able to do that? And do you have a time frame on that?
Yeah, so it's effectively just making it in series. So it's just putting it on top of each other. That's all it is. And whilst that may sound complicated, it's not that complicated. But then obviously at nanotechnology level, you do need to make sure that it is working functionally otherwise. So, we have done it, but we need to do it in the right battery, and we need to make sure it functions properly. And then we need to get it to a steady, repeatable basis. So those are the steps, and we're pretty confident that we can do it. It's been done before in lithium batteries. It's been done before in other types of batteries. So, we don't think it's insurmountable. And the time frame, well, to be quite frank, the time frame is how do we prioritize it amongst some very large companies talking to us about doing other things. That's the problem, is prioritizing that work against doing some other big company requests that keep coming, quite frankly. So you've got to either choose to do development work or choose to do some work that may answer some big company requests, and this is what we need to do, is increase the team size, and that's definitely what we plan to do to work through that.
Okay, there are a couple high-level questions that keep coming up here, so I'm going to run those through you right now because we are running a bit long on this and we will have to wrap it up. But one deals with weights. How does the weight of a lithium-ion battery compare to the batteries that you are producing?
So your weight of these batteries is, because we're only at coin cell, and that's got to be understood, that the coin cell has got a lot of volume and weight constraints, which means the data is not particularly useful for pouch packs later or for EVs, because you've got a lot of space that you can't really use, and the weight of the battery is, the coin cell is much higher, bigger than the actual weight of the internal cathode electrode anode. So all I can say is it's a very light battery. The coin cell is a very light battery, but I think what the question is pointing to is, what's the energy density? And you don't really talk about energy density for these coin cells. So I think we'll keep you posted on that. When we start doing pouch packs, then that's when we can start doing energy density, because it's more of a thin film factor, and we can do some much more meaningful numbers for people for both volumetric and energy densities.
Okay. How about temperature wise? If the temperature gets really cold, 0 degrees Celsius, -10, -20, even -40, have you done any research on that, how these batteries function at lower temperatures?
Yeah, I think the data shows that there's no real performance difference on external laboratory for other types of batteries like this at kind of university lab level. I think we might have done some low temperature testing some time ago, but we need to do more conclusive testing. We're not expecting a big problem. As you probably know, lithium batteries do suffer a range of performance drops outside the preferred temperature. I don't think ours will be anywhere near as much, but we need to do the testing to validate that. There's really no reason why it would become an issue. There's a hybrid supercapacitor batteries, so you're actually providing the energy density through electromagnetic forces or fields, which is very different to how you have it for lithium-ion batteries, which is through ion transfer. So aluminium-ion batteries uses ion transfer as well as electromagnetic force to distribute the capacity, which is why it's such a breakthrough battery. And you don't affect electromagnetic force with temperature. So that's why there's a solid feeling that this won't be a problem at high and low temperatures, but as I said, we need to test it.
Okay. Pouch pack wise, a lot of people are wondering, is this for EVs? Can this be simulated into the EV market? A lot of EV commentary is around lithium ion batteries. What insights can you give us in terms of the potential here to enter the EV market?
Yeah, it's definitely a potential for EVs, and we do have vehicle companies that have reached out, and we are talking to some. So it's definitely got an opportunity to be used in electric vehicles, electric aviation, and in others types of transport. So we'll that obviously have very different design requirements to what, say, coin cells might need or personal electronics, but we do have the scope of within our battery current knowledge to be able to be used quite effectively in vehicles and replace lithium batteries.
Okay, let's keep going here. We are running low on time. Everybody, thank you for all these questions. There are a lot of questions that have come in, and I'll be setting up a follow-up call more on a regular basis with Craig to take care of these questions in a bit more of a consistent fashion here, I guess. But Craig, continue on, please.
Yeah, so I think we've got a few more slides, and then over to Chris, who's been very patiently waiting. Thanks, Chris. The 4 key areas that we're focusing on are, as a team, as I said earlier, we're focusing on the customer and industry partner engagement for developing the battery at scale and getting customer data back, which we've talked about, which we're still waiting really, but also looking at industry partner supply chain partnerships, and a bit like Bosch, but in other parts of the supply chain. We're obviously working on the pilot plan development and looking at full technical transfer of the IP from UQ across so that we can get our batteries performing as highly as the UQ batteries are. We don't expect that to be taking too long, but we need to do it. We've only been operational for a month, and those who are joining us from the Northern Hemisphere, we've just been on our summer holiday. So, we'll come out of that. We're in a bit of malaise. So we'll come out of that with also a bit of a COVID peak in February, and I think we'll be pretty strong in the March when that should be really pushing up to the limits of where UQ's at. We're really pushing our thermal XR into different channels. Obviously, also trying to grow our team in this area as well. We've now got we're talking to OEMs in this space because we can now see energy reduction, 10% or so, which OEMs will pay an enormous amount of money to go and get otherwise. And ours will always provide that almost regardless of what the air conditioning is doing, which is the unique thing about this product, because it affects the heat transfer of the coils, and there's pretty much no other way of doing it. And that is, we are definitely very focused on achieving significant revenue as early as we can. The next item is probably best described through sharing some image. So we have some graphene images for you guys to see. So we're obviously tuning our battery, our graphene production system to be able to make battery-grade graphene every day. That's the most important thing to be able to make the batteries. So here you have on the left-hand side a picture of some what we would call a medium quality graphene. It's these beautiful flakes. They're 3 to 5 atoms high. These are obviously made by GMG in our plant. And here you'll have some particles. Now the graphene flakes are exactly what we're hunting for. That's what we want. These are obviously electron microscopes. It's about 50 to say 200 nanometers wide, these flakes, and they're slightly rumpled, which is really nice as well. So we would be able to take those flakes and make them into great batteries. This, not so much. So if you did use this in a battery, it would still function. It would still work, charge really fast, but it wouldn't have a really high peak energy density, which obviously, the top batteries would. You'd want to have them. So you could put this into an energy storage battery potentially, where you don't really need to, in a house, for instance, you don't really need to have high energy density because it could be a bit bigger and heavier. This is the type of graphene we want to produce every day for our batteries. It's beautifully thin, 3 to 5 atom high, with slight crumples, and you can see how transparent it is. This is how thin it is. And that would make and has made beautiful batteries. And that's what we're trying to make every day. And that's what our production operators, production team, and our engineers, scientists are working on, how to make this every day. And as you can see, we're pretty close, and obviously we have made it, but we want to make it every day, every time we want to, and then convert that obviously into a battery as the final product. That there alone is an enormous business opportunity to be able to make that every time. That graphene could be used in any battery and increase its performance on pretty much anything that it's put into. But we want to use it for our own batteries up front, and because we think that's the way to really bring impact on, and obviously create money for GMG shareholders. I might hand it over to Chris.
Thanks, Craig. Thanks, Corey. Corey, I'm conscious of time, so I'll shorten mine up into 3 main points that I wanted to make. Firstly, I know people are always interested in the cash position because of the timing of this webinar and the fact that we've got an interim financial report about to come out. I can't talk about our latest position just yet, but at September we had $14.1 million in cash, which we consider adequate to fund the next stage of our technical development and capital plans. So that's operating and capital expenditure for at least the next 12 to 18 months. The cash is fairly stable. One of the reasons for that is that we have options and warrants on issue at 30 September, which I wanted to highlight. If those are exercised, as they gradually tend to be, that'll provide additional funding from exercise proceeds of up to $13.1 million for very manageable levels of dilution. So in times of rising share price, as we're seeing now, and even after the pullback in tech stocks, that's a nice way of keeping our cash resources fairly stable to growing for the time being. And finally, I just wanted to draw people's attention to one of the items, or a couple of the items we saw in our financial statements at 30 September, and you'll see moving forward again for the time being, which is the new financial liability and associated gain loss in the income statement that we have now with marking that liability to market each quarter. It's a technical IFRS requirement. It results from the fact that we've issued warrants in a different currency, being Canadian dollars, to our functional currency, which is Australian dollars. Those standards view that situation as a derivative rather than equity, as you would normally expect. And the thing with this liability is that it can be quite volatile, and the movements will be reflected on our income statement. In particular, where you see rapidly rising share prices, you will see an increase in that derivative liability as we mark to market at each reporting date. And then over time, we'll see that liability gradually wind down as those options and warrants either expire or people exercise them, and the associated amounts moved into the equity section of the balance sheet. But what I wanted to emphasize is that there's no cash impact and there's no need to pay the liability, which may seem difficult to understand, but those are the accounting standards we're dealing with, and we're not the only foreign issuer dealing with this issue right now. So what we've done is to try to do our best to show this amount separately in our quarterly MD&A release so that you can clearly see its effect, but it won't affect our cash outlook.
Okay.
Thank you, Corey.
Absolutely. Hey, I'm an accountant too, so I know sometimes these rules add some nuances to the financial statements. Craig, two more questions that we're going to take care of here. Everybody, sorry if we did not get to your question, but as I mentioned, I will have Craig back on for follow-up interviews, and we'll go through what came in. We're probably well over 100 questions. So a lot of activity, a lot of people interested in this story. A few people were wondering, why are you looking to use other sources of graphene if you are producing and you have produced that high quality graphene for batteries?
Yeah, there's two areas. So my main job is to manage supply, demand, and finance. So those three windows are what my job as a CEO. And if I've got more people wanting the battery than I currently have graphene, and somebody else can give us the graphene, I'll take the opportunity, make the batteries, and take somebody else's graphene and make that into cash. So that's the first thing. So I'm managing the window through the supply window, so I don't have to go and build more graphene straight away and take somebody else's, because there are a lot of graphene companies out there that just haven't got applications. But what I can say is there's very few companies out there that probably less than on your hand, fingers on your hand that can actually do anything like that, and maybe even less than that, really. So it's our search is not laborious. We're not looking desperately, but we are just out there seeing who is there to work with us, and if there's something there to tack on to what we're doing, great. Bring this to market faster. But second is what we do know is that there will be a range of aluminium-ion batteries of quality, and the really high quality will be using potentially our graphene, and there might be lower quality batteries that still work quite well and have very fast charging, but they have less energy density, and it might be best with somebody else's graphene potentially. So product differentiation also is a great strategy, to kind of launch this on, and that's something else that's going on in our minds. So it is, carbon is carbon, and it's it's obviously the most abundant element, I'm pretty sure, apart from hydrogen. So there are many different ways of making it, and we're just being open to that. But nothing is more focused than our operators and our engineers, scientists making that graphene every day to tune it as well at the same time.
Okay. And now, Craig, wrap us up with a general message to shareholders. What can they look forward to, especially this year, 2022, for the company?
Yeah, I think that we really want to come out with some supply chain partners who can help us collaborate and move the battery faster. We also obviously want to come out with some results on what our customers have said to us. When we get results that come back from our customers and say this is what it is, we obviously want to come out and share that. And then we want to get to significant revenue as fast as we can. Now, once we get to that significant revenue, then I think there will be awful lots of opportunities to grow and fund us, some of our own growth just through our own revenue. So, which is obviously a very attractive proposition. Then once we've got our pouch pack plant switched on, the amount of opportunity for our battery is multiple times more. So then the complexity is of how to actually pick a partner in the battery application space is going to get more important. But until we get there, I can't really say that we'll pick a partner, but it could well happen that we'll have to do that just to be able to align all the requests we're getting.
Okay.
So I think push for more revenue and get the battery up to be able to get to scale as fast as we can.
Sure. Judging by the questions, a lot of people are waiting for that revenue and waiting for that higher scale too. So you have a lot of people following very closely with this story. In full disclosure, I am also a shareholder of GMG. As I mentioned, we could not get to anywhere near all the questions that were sent in, but we will be talking through those questions. Craig and I, in future interviews, I'll make sure I set it up in the next couple of weeks. You can always email me any follow-up questions, fleck@kereport.com. You can reach directly out to the company through that contact information on the screen. So, Craig, Chris, I know everybody here really appreciates your time. So thank you for this bit more comprehensive update on the company.
Thanks, Corey. Really appreciate it as always. Talk soon.
Thanks for having us, Corey.